Hello all, and thank you for joining today. Let's give it a minute, wait for others to join us, and then we will start. Hello everyone, and welcome to the webinar, An Integrated Approach to Scanning APIs with DAST. Before starting, I would like to give brief information about myself. My name is Suha, and I have been working at Invicti for over 2 years. I have more than 30 years of experience working as an application security professional, previous 12 years. So today's agenda, I would like to talk about a few challenges while providing API security, best practice for scanning APIs in DevSecOps, and the best solutions for accurate API scanning by creating a baseline. But before we dive into presentation, I would like to introduce who we are. Invicti has been a global leader in web application security since 2005, with its headquarters based in Austin, Texas, and branches located in Malta, Turkey, and Czech Republic. The company has established as a result of merger of two prominent cybersecurity firms, NetSparker and Akyuz, which brought together their extensive expertise in web application security. With a dedicated workforce, over 300 professionals, Invicti has earned a reputation as a reliable partner in the cybersecurity industry, having secured over more than 800,000 applications and serving more than 3,600 customers worldwide. We offer accurate and automated web application and API discovery and testing, of course, that's integrated within the secure software development lifecycle, secure SDLC. Invicti's testing technologies, including dynamic application security testing, DAST, in interactive application security testing is called IAST, and software composition analysis, SCA, all are fully automated through the SDLC. APIs are crucial in modern software architecture, serving as fundamental building blocks for web applications and facilitating efficient data exchange and business functionality within microservices. However, this increased reliance on APIs also raises security concerns. Undocumented API endpoints frequently find their way into production on the wild and expanding the attack surface and making applications vulnerable to cyber criminals. As the number of web applications breaches continues to rise, it becomes imperative to prioritize truly security testing and implement robust measures to protect API endpoints and the overall attack surface. Let's quickly take a look at the cybersecurity landscape. According to the latest API security trends reports, 95% of companies have had an API security incident in the last 12 months, with API attacks growing by 681%. 40% of data breaches stem from attacks on web applications, according to the latest report from Verizon Data Breach Investigation Report. And 96% of applications have at least one vulnerability, which only takes one to get breached. A comprehensive study completed by Akamai Threat Report in 2022, current and historical data notes that 44% rise in publicly reported cybersecurity incidents over the past decade, with a typical cost of more than $250,000 per incident that grows to $52 million for the top 5% of incidents. In response, organizations must protect themselves with a defense in-depth approach and have a robust framework that reaches back into their software development practices to ensure that the applications they build are inherently more secure. While most companies are aware of the need of APIs, scanning APIs, there are some very real practical challenges to be overcome and on the way to making API security a routine part of your web application security. Under pressure to add API testing to an ever-growing security backlog, AppSec professionals often need to help finding the right tools and workflows. API endpoints need to be tested for vulnerabilities for sure, just like any other part of the application. So it doesn't become a security blind spot. We have to complete the chain. However, there are many challenges to overcome on the road to systematic API security testing. Let's look at some of these obstacles and peel back the layers of complex API puzzles. But before we dive into challenges, I would like to talk about the terminology first to clear any confusion. Application programming interfaces are precisely what it says on the tin. Interfaces for programmatically interacting with application, of course. This means that there are two separate levels of security involved. The first one is securing access to the interface. Means all requests incoming to the private web API must be suitably authorized to be passed to the application. Attackers focused on this layer of security will attempt to break or bypass authorization to obtain access to the API and send requests or attacks to the applications. And the second one, at its core, an API is another channel for interacting with the application that needs to be included in application security testing. At this level, API security means securing the application against the web attacks that arrive via the API, and we will focus primarily on the latter aspect of API security, showing how to incorporate API vulnerability testing into broader web application security program. Let's look at the challenge number one, the sheer number of API endpoints to secure that leads to an issue of scalability. So you're asking yourself, how am I supposed to test thousands, hundreds, or maybe thousands of endpoints? This multiplies all other challenges, of course. First of all, there are several types of web APIs. While REST is by far the most popular API architecture, more complex or older business systems may use SOAP, while cutting-edge applications dealing with big data are likely to rely on GraphQL. Before choosing a type-specific tool, you must poll at the development teams about the API types and they currently build, maintain, or plan to add those types. Assuming you get this information and it is accurate, you may need to support more than one API type, maybe even all three, which could mean three separate tools to accurate, integrate, and manage, which is another challenge. The next multiple choice question is about API definition formats. Across the three main API types, there are at least a dozen popular definition formats and several more proxy export formats you might need when you don't have complete definition. Which ones do you need? So you have more pooling, planning, and potentially multiple tools to run and maintain for different formats. It's an overhead. And this is all before looking at the number of API endpoints to add your vulnerability testing workflows and the number of different scan results to process. Adding only a moderate-sized external REST API can mean several dozen additional URLs to scan. But what about service-oriented architectures? If you have an application comprising 100 microservices, you have 100 more service API to scan. And what if you have a dozen such applications and each API yields several scan results? Without a careful and centralized approach to API vulnerability scanning, the multipliers will keep piling up, threatening to overwhelm already overstretched security resources. To take control, you must simplify, reduce, and not multiply and complicate. Here is simplicity is the key. Challenge 2, knowing and maintaining the endpoints. Getting the API definitions from developers, and because you can discover them by sense, because as you know, APIs are black hole, we cannot crawl it. Ideally, every time something changes in the development process, maybe daily based, and ensuring support for various API types and definition formats, all this is a challenge. And additionally, validating the API itself is another challenge here. When doing API security testing, the fundamental difference compared to web application testing is that you can't simply fire up a crawler and crawl the APIs to find your test targets. API endpoints are black hole. It needs to be provided. The only way to be sure of covering the entire API is to have its definition file, valid definition file. And that means getting the current definitions from your developer. Most of the time, it is a burden for you, for security engineers, because APIs can change rapidly. You would ideally need to do this before every security testing. In any sizable development organizations, doing this manually, regular would be a major headache for the security team, an extra core for the developers, of course. Even assuming you can spare the resources and time to collect definitions manually, the complexity issue rears its head again as soon as you start looking at specific definition files. Unless you have standardized API policies in your organization, you could end up with a dozen formats for various architectures and API platforms, which typically means multiple tools for importing and testing. And keep in mind that it's unlikely for every APIs in your environment to be known and documented. Not when it is so easy to create temporary API endpoints that later slips into production without official testing or documentation. While it's possible to discover API endpoints by analyzing web traffic, it is at best a stopgap measure. Having up-to-date definitions for all your web APIs is must to avoid security gaps. And challenge 3, accuracy and authentication. You might be asking yourself, how can I ensure the same quality of testing all across the environment? Yeah, even assuming a scanner that works well with modern websites and applications, I know that scanners often stumble on authentication, and that's a critical requirement for APIs. Authentication is now vital for web security testing, especially with business applications that serve very little data or functionality to unauthenticated users. So the main purpose here is covering the whole surface. This goes doubly for APIs, where unauthenticated vulnerability scanning would be more or less pointless. But many vulnerability scanners have, historically speaking, struggle with automated authentication, even on user-accessible sites, leaving some users wondering whether truly scanning an API for vulnerabilities is even possible. Compounding these doubts are lingering misconceptions about the accuracy of automatic vulnerability scanning in general, rooted in a deep mistrust of legacy scanners designed in the days of static websites. Faced with modern JavaScript-driven web applications such as single-page applications, SPAs, where a dynamically generated front end communicates with a service-oriented back end via APIs. Legacy tools can miss vast swaths of the application attack surfaces. When you add authentication and authorization along with modern enterprise must-haves such as single sign-on or two-factor authentication, a scanner that can't authenticate and then run a true test is worse than no scanner because it gives you false sense of security while doing very little valuable work. In the same way that keeping up the latest web technologies and application architectures requires non-stop research and development. Keeping up the web vulnerabilities and adding security checks as soon as new attacks are discovered is also a full-time job. Creating, maintaining, and running automated security tests are balanced performance and accuracy is hard enough for interactive websites and applications. When you add the complexity and opacity of APIs, you raise the bar, the level where very few tools make the grade, even before considering the practicalities of making it all work in your existing organizations. And challenge 4, remediation and efficiency. Simply, we call this vulnerability orchestration. Pain points that we see organizations experience. How do I get vulnerability reports to developers and get fixes from developers without delaying the entire pipeline? Because most of the companies are using agile project management. In an agile project management, sprints have limited timeline, so they have to develop their codes and then conduct the security testing and get the report and make the remediation. So they do not have enough time to wait for or pause the pipeline. Each external tool and process outside the existing toolkits means friction and extra effort. What about fixing, retesting? It's another pain point. Let's assume for a moment that you have successfully negotiated all these hurdles, and found a way of running vulnerability scans on your web applications, APIs regularly. Depending on the size of your application environment and the maturity of your AppSec program, this could mean hundreds of vulnerability reports arriving with every scan. Now what? Simply running a scan does nothing to improve security. We have to process the outcome. To make your applications more secure, you need to identify and remediate real vulnerabilities before they make it into production to the wild. And there is a long way to go from scan results to fixes. Automation is crucial, and automation is the game's name in the web development, especially with agile methodologies. Yet, security testing still tends to get manual treatment. This is due mainly to lingering need for more confidence in the accuracy of automated scanners, combined with historical limited integration capabilities. To avoid flooding developers with false positives, overworked security teams get burdened with double-checking scan results and manually assigning only actionable issues to developers. When dealing with APIs, you are upping the ante by throwing in even more significant numbers. Handling all those additional security checks is acceptable for any half-decent vulnerability scanner, provided it can access all the test targets. But extend application security testing to include your APIs, and overnight find yourself facing double or triple number of vulnerability reports you had before. You would better be sure they don't contain false positives. It's waste of time. Or you won't be able to feed them into development pipeline for remediation. That would be costly. Integrating security testing with existing tool chain is another common headache regarding to the development pipeline. With purpose-built integrations with industry standard issue trackers and CI/CD platforms, organizations can roll their solutions by gluing together disparate tools and formats. Each new device means another integration project, and depending on the specific products and technologies, the results can be far from seamless, pulling developers out of the optimized workflows and introducing friction and delays, of course, into the highly automated pipeline. Well, what are the best practices then? Let's have a look on the best practice for these challenges. To be effective without burdening your security and development teams, API vulnerability scanning must be a routine yet unrobust part of your web application security program, which means tight integration with Secure SDLC. Because APIs are defined and modified in development, you need to build automated API security testing into development pipeline to be sure you are catching all changes, no matter how frequent. It can be daily. Most likely in DevSecOps, it's going to be daily. Based on hundreds of customers, stories, and over a decade of supporting organizations in deploying application security testing, we have compiled a collection of best practices for integrating API vulnerability scannings into your broader application security program. Making API vulnerability scanning a technical reality. How we can do that? Modern solutions finally make accurate API scanning a reality. A crucial prerequisite for addressing all these challenges and smoothly folding web API security into your wider application security program is having the technical ability to make it all work together. With API endpoints adding yet more moving pieces to do already complex patchwork of web development, starting from the outside and working your ways in is the surest way to maximize security testing coverage regardless of underlying complexity. And that means dynamic application security testing, or DAST. Building on the mature and proven technologies of acclaimed Invicti vulnerability scanner, Invicti offers a pragmatic DAST first approach to web application security in general and web API security testing in particular. There are the industry-leading technical capabilities of the Invicti solutions to help organizations to secure their API endpoints. First, cover all major API types and definitions. It's important. Adopting a unified approach to API vulnerability testing starts with knowing what API types you are in used in your web application environment, listing the API endpoints to be tested, and last, having the technical means to test them. Invicti has all three major web API types, REST, SOAP, and GraphQL, covered out of the box, and with built-in dedicated security checks and support for various ways of importing and discovering API definitions. In this mean, we do support three different ways. So you can import your definitions manually by writing endpoints one by one, or importing the definition files. It can be Swagger, it can be WST, ADL, or any other kind of format. Or you can import your definition files from central repository by using the URL. That's a really good solution for DevSecOps. You can keep all your definition files in one box, in one centralized, and then you can get the required definition files per scan, and you don't need to update anything. It's fully automated. Importing definition files and schemas. The sheer number of different API definitions formats used to be a major obstacle for centralizing API security testing, often requiring multiple tools and complicating the process. Invicti comes with a built-in support for 15 different formats, including Postman, OpenAPI, Swagger, and WADL, and WSDL, and much more. And as I explained, we do support centralized definition file import by using the URL. You don't need to import anything. The scan itself imports the definition file. And discovering additional API endpoints. Having the definitions is crucial because as we stated, you cannot crawl an API as you would you do on web applications. You simply have to know the endpoints and request formats. In the real world, though, there will be times where you are dealing with undocumented APIs that you still need to test. To help with this, the Invicti scanner automatically imports any supported API definition files that it finds during crawling. But that is only a small part of its discovery capabilities. When crawling your websites and applications, Invicti examines the structure of the URLs it encounters, and if it finds a URL that looks like an API call, it will attempt to interfere the API endpoint and test it. This includes heuristic URL rewriting to discover underlying request parameters and probe them for weaknesses, just like an attacker would. In this mean, this is addressing scanning microservices. In microservices, most of the time there is a front-end application that communicates with APIs on the background. So if you are scanning the front-end, and if you cover those APIs in the scope, you don't need to import API definitions because the front end is going to make calls to the APIs, and we will be catching those API calls. As long as you keep those APIs in the scope, we will be scanning those API endpoints as well. And authenticate automatically. Automated authentication is a practical prerequisite for API vulnerability scanning. As the scanner has to obtain API access token before it can test the underlying applications, Invicti provides major support for popular API authentication methods, including basic HTTP authentication, JSON Web Tokens, JWT, and Auth2. With Auth2 support, you get the ability to scan in single sign-on environments, which can be problematic for less advanced scanners. And we do support all 4 auth dances in details. But if none of these standard authentications are not working, we do still support complicated authentications by prerequest scripts. By making the required request and get the response and make another one if it's required and get the response and pass the result and get the required tokens and authentication headers and put it in the original request. Test for vulnerabilities with consistent accuracy. With authentication setup and test targets discovered, Invicti can use its entire battery of high-quality security checks to safely probe the full application attack surface for vulnerabilities, covering both UIs and APIs. Proof-based scanning technology is used to automatically confirm the exploitability of the vast majority of direct impact vulnerabilities with no risk of or false positives. Being able to trust vulnerability scan results and act on them directly without fear of false alarms and tedious exchanges with other teams is still a rare experience for organizations. In this means, we can provide you more flexibility here to provide accuracy. Streamline applications with one central platform. By treating web APIs as an integral part of the overall web attack surface and scanning them for vulnerabilities using the same centralized platform, the Invicti approach simplifies the AppSec program instead of adding yet more moving pieces. What are the takeaways? Well, the bottom line is that vulnerabilities cannot be ignored at any point in the software development lifecycle. Indeed, identifying and managing all threats can be daunting, but when faced with the possibility of an attack that could derail development or worse, cause a breach for customers' deployed software on the wild, testing for vulnerabilities both early and often is more than an obvious solution. It's the specified standard. It saves your project from scope creep and other pillars. Benefits of vulnerability scanning. Testing tools such as Invicti AppSec solutions continues to work on all phases of CI/CD pipeline, scanning during development to validate code, scanning pre-production systems to validate the environment, and scanning test systems to validate production code. Integration within build tools fundamentally important, and you get notified automatically with the vulnerability for that code segment and providing remediation techniques to fix the program. A big advantage of Invicti's DAST tools is that we provide automatic confirmation for the majority of important vulnerabilities to prove they are real issues and not false positives. In other words, when a vulnerability is identified, we attempt to safely perform a test attack. We do not use any harmful payloads, and we do not try to extract any sensitive information, just enough proof you to convince, and then retrieve a piece of data as an evidence. And this is why we provide AppSec with zero noise. Additionally, about the vulnerability orchestration, we do provide bidirectional integrations, which allows you to automate whole your pipeline since you start the scan to the apply the fix. Everything can be automated, and automation is crucial in DevSecOps, as you know. Well, thank you for joining the webinar today. I hope the information has been useful. And now, let's open up for questions, and please feel free to submit these questions on the chat box. And if we won't have time to cover all of the questions, we will get back to you after the webinar. Okay, I can see the first question is already on the chat screen. How can you integrate API scanning and business application scanning if such environments are often gated with business logic, which cannot be understood by automated application or by complex authentication schemes? Nice question. Well, yes. As a dynamic analysis tool, we simulate the attack, every single attacks from the client perspective. And we try to combine every single possibility to simulate every single possibilities. But what if you have very specific business logic in the application? For example, you need to pick something specific in the pull down menu on the next screen. You need to write very specific string somewhere. And on the next screen, you need to pick another thing. And as a result, you end up with a hidden page. So dynamic analysis tools, DAST tools cannot follow up this kind of specific tools. How we overcome this problem? Then let's talk about business logic recorder and other mechanism in Invicti that makes possible recording. Well, our business logic recorder, you simply can record these very specific flows in your applications. And after you record this logic, you can save it and attach it to your scan profile. And then when you start scan, after the authentication, of course, we run these logics, recorded logics. And then on the way, we capture every single request and response and endpoints, discovered endpoints, and we start attacking these hidden pages and endpoints as well. This is the solution we provide. Well, I can see another question here. You have talked about best practices and it's all very well and good. Thank you. And but I am still not clear what exactly your company does to help with all this. Is there anything unique about your approach that makes it all somehow easier to implement? Another good question. Thank you. And as always, with the best practices, we are sort of talking about theory or strategy, and there are many ways to get there. And the Invicti approach is based around having a DAST-based platform, so making dynamic testing the foundation of your AppSec. And this is different from your most security vendors who have been treating DAST as as this add-on feature, not as the primary testing method. Often because they have relatively low quality DAST, they cannot depend on the results and only treat them as an additional source of information. The reason we at Invicti can make this work is that we have been building out the core vulnerability scanning engine for over a decade now. And with things like proof-based scanning, we get very accurate results. So you can base a whole application security program on top of that. And then because it's dynamic testing, it's technology agnostic and easy to set up and integrate. So our customers are able to apply these best practices to their actual development and production environments very quickly. Well, another question. There are lots of questions, I believe. Okay, in one place, you said something about avoiding false positives. Yes, I did. All security vendors are saying they have fewer false positives or no false positive. So how does this work in your product? That's a great point. I think everyone here sort of roll their eyes wherever you hear another security company saying that they have no false positives ever. And of course, that's simply not true. And I have seen lots of research about showing that in all areas of cybersecurity, false positives are major nonsense and a major source of frustration or even burnout. So the key to dealing with false positives for Invicti is automatic vulnerability confirmation, which means that our scanner attempts not only the identifying vulnerabilities, but also to safely exploit. Safely is the keyword here. We do not use any harmful payload. Safely exploit them to show that there are real issues. It is present. And if this works and the application reacts in a very specific way that is only possible if your test attacks was successful, then we can report these results and show that reaction as proof and say this is exploitable. Our scanner managed to exploit it. Here is the proof. So you know that this can't be a false positive anymore. And the scanner provides this kind of accuracy for majority of high impact vulnerabilities. So you can immediately ask your developers to fix these issues, even down to automatically creating tickets, because if it's confirmed, then it's exploitable and cannot be a false positive. Additionally, if you are using interactive scanning IAST tool in your scan, if you attached IAST feature set in your scan, IAST can provide you more details. For example, if it's an SQL injection, from the client perspective, we can provide you proof of exploit or proof of concept, just the URL and the payload. But IAST helps us to address the root cause of this vulnerability by providing the exact file in your application. For example, it says, look, in this file, in this line of code causes causes an SQL injection. So this is better because we address the exact point of the root cause. That means developer does not need to check the whole bunch of application where the problem is. IaaS can address them, and then they can easily find the problem. Another thing is about the false positives. We use two different terminology here: possible and confirmed. If we use confirmed, that means we are 100% sure, and we provide you POC, POE, and even if you are using IAST, we provide you the address of the vulnerability. But if we use possible term in front of the vulnerability, most of the time people think, oh, you say possible, but it's false positive. No, it's just heads up. So while detecting one vulnerability, we don't use just one payload. We use bunch of payloads, let's say 10 payloads for the same vulnerability. But for example, 7 of the payloads were successful, but not the last 3. So in this case, we are not sure, but we need to warn you. We need to make some heads up here. So that's why we use possible terminology here. We still provide you proof of concept, and we give you confidence level in the vulnerability details. It can be 60%, it can be 70%, it can be 90%. So it's not just false positive. There is something we couldn't prove it, and it's just heads up for you to check it. Well, thank you for your time. If we haven't addressed your questions, we will get back to you after the webinar.